Good morning, physics. In this video, I'm going to be explaining what was done in the Inelastic Collisions lab to collect the data for you, and as well give you a couple of pointers on how to complete the analysis. So the first thing that you need to do is answer the preliminary questions about Jocko and the ball. Jocko's on skates, and he catches this heavy medicine ball. And so it is up to you to determine their final velocity together. So this is going to deal with inelastic collisions. And it is important for us to know that the ball and Jocko will be moving afterwards. So we are going to be replicating that here with our setup. So we have two carts. We have the ball cart on the right side and the Jocko cart on the left side. Notice the Jocko cart's got a little bit extra on it. It's because if we are using two lab carts, they're going to be the same mass, but that is not the situation that we have in the preliminary question. So we have our track here that the Jocko and ball carts are on. And what I did was I had a motion detector over here that collected the position and velocity data of the ball cart at all times, because at some point the ball cart is going to collide with the Jocko cart and they're going to move together. So as long as I have the velocity of the ball cart, I should have the velocity of both of my carts at all times. So just to give you an idea of what happened, so I gave the ball cart a push and it collided with the Jocko cart, and then they both move together afterwards. So see how if I can get the motion data of the ball cart at all times, then I have the motion data of both of the carts, right? Because the Jocko cart is stationary to begin with, and after they collide and stick together, they will have the same velocity because they're sticking together. Now, when you're doing the momentum calculations, right, we want to see if momentum is conserved. What you're going to do is you're going to initially find, right, the momentum of the ball cart. That's going to be some number, right? And the momentum of Jocko at the very beginning is 0. So afterwards, the momentum is going to be of them both. So of the ball and Jocko. So when you're doing that, right, it's always going to be mass times velocity. You want to use the mass of them both together. So you have to add the mass of the ball with the mass of Jocko. So be careful as you solve this, as you work through the different trials. Make sure to add up the two masses when you're solving for the final momentum. With that said, that should give you enough to work on the lab. If you need help, remember to sign up for office hours.